So, hi everyone in front of the screen. My name is Carola. I'm living in Hamburg in Germany. In the background, you see my garden in France. I have a husband who is French, so sometimes I'm there, but this is just the summer look. So I want to talk to you today about my experience with microservice architectures and how a microservice architecture should look like. Before I dive into this topic, I have two slides about my company and myself. My company is called WPS Workplace Solutions. We are in Hamburg and in Berlin, and we develop great software with an amazing UX design and a sustainable architecture. This is our great focus, our goal when we develop software. We started in 2000 with 12 developers, and nowadays we have grown since then to 130 developers. And of course, at the moment, we all work from home, but slowly employees start to return to the office, and we enjoy to meet each other in person very much. And I hope I will meet you all in person soon on the next conference. I'm sure this will arrive soon, next year at least. I've studied computer science in the 90s and programmed a lot of software in C++ and Java. And in 2008, I handed in my PhD thesis with the title Complexity of Software Architecture. I then turned this into a business model for our company, and we analyze and evaluate complexity of software architecture, and we check whether the systems that people have are sustainable and how many technical depth they have. You can see I have written a book about that, sustainable software architecture. So some of the advice I give you today is as well in my book. But it's from 2019, and I'm about to write a new book together with Henning Schwentner, who was here today as well, about domain-driven design and microservices and monoliths. So a lot of it is already in here, but the new book, well, we are still writing it, so we will see. Well then, what is a system with a good architecture? What do we want? What is sustainable architecture? Well, what we want our architecture to have is a long, useful life so that it pays off our investment, of course. We have invested a lot of money in this software system. And this means you have to pay off your investment. This means that we want the lowest possible maintenance and extension cost. This is clear. And this is only possible, from all I know, if our architecture is easy to understand, easy to change, and easy to extend, because then we can do this quickly and the cost is low, and thus our software will pay off the investment. So this diagram illustrates our goal visually. We want to keep adding a singular number of features to our system for a long time to go. So on the x-axis, you see the number of delivered features per release, and the time the releases are over here. And we actually would love to be up here on this green line. But unfortunately, complexity and technical depth prevent us from doing so, and we end up with a sad norm down there on this red line. During and after my PhD thesis, we've analyzed a great number of systems of different sizes and programming languages. And on this slide here, you see a pie chart. In the middle, the pie chart shows how many systems in different sizes we were allowed to look at. The light blue up here, the 120 systems that were small systems up to 100,000 lines of code. Those small systems are usually apps on mobile phones or very small applications in their first version. Many other systems out there are much bigger, like 500,000 lines of code, or 1 million, or 5 million, or even 15 million lines of code. And many of those systems are developed with modern programming languages like Java, C#, .NET, TypeScript. You can always discuss, is this modern or not, but they are programmed in those object-oriented languages, but they frustrate their developers because they have accumulated technical depth and complexity over the years. And unfortunately, some of them are microservice architectures, the great new architectural style that was supposed to solve all our problems when we were told about it around 2012. It used to be that people would call me and say, Carola, we have a legacy system and we need help. It's getting more expensive and slower to maintain. Can you help us and break the system up into microservices? And today they call and they say, Carola, we have a microservice architecture and maintenance is getting more and more expensive and slower. What are we doing wrong? Yes, what is wrong? Well, with a lot of microservice architecture, people have made the same mistakes they made with monolith before. I stole this diagram from Simon Brown, you see him on the right down there, because it explains so well what was forgotten. On the x-axis, you see modularity, and on the y-axis, the number of deployment units. And the people forgot that microservices, a microservice architecture is about creating independent modules. A modular architecture, that is an architecture where someone pays attention to modularity, which is the opposite of a big ball of mud. In a modular architecture, modularity and dependency control is a top priority. If not, then you have a big ball of mud. No matter if you have a monolithic big ball of mud, or a distributed big ball of mud. If you have either of these, so low modularity, then your system probably looks a bit like this. This diagram is a class cycle, a strongly connected component. Each rectangle over here is a class, and the lines between the rectangles are the dependencies between the classes. So in here in the middle, there are a lot of dependencies, and it's almost dark because there are so many lines. The color of the rectangles indicates that they belong to different modules. So there are some who belong to a green one, some to an orange one, some to a purple one, and so on. The whole system has 3 million lines of Java code, and this structure here with 463 tangled classes contains 500,000 lines of code. So it's almost, well, not half of a system, of course, but 6 of the system. If we divide the whole system into 6 pieces. So 30 developers have worked on this system for 15 years. And if you change one class in this cycle, you have to check the whole cyclic structure to exclude possible effects. This greatly slows down maintenance and enhancements. So we try to help them to break this thing down. Another example, even bigger, these are 10 million lines of code developed in Java as well over the last 20 years. When those people started, nobody told them about microservices. This idea did not exist at that time. And as a result, now you have 90 different modules strongly connected, a whole lot extra work for maintenance and enhancement here. And nobody has reduced or controlled the dependencies in these complex structures. So what can we do to prevent this in our microservice architecture? What is the solution? And before I go on, you know, if you have questions, just put them into the chat. I will have a look at the chat. If it's something that relates directly to the topic I'm just talking about, I will try to answer. And if not, I will answer your questions afterwards, okay? So the question here is now, what can we do to prevent this horrible structures full of dependencies in our microservice architecture? Well, the answer is easy. We have a very old principle at hand to prevent these big ball of mud in microservice architecture. And this old principle is high cohesion and loose coupling, which means within a module, the classes or the submodules or the packages should work together to fulfill one responsibility. The wonderful single responsibility principle of Robert Martin is perfect to describe this. This responsibility connects the classes, modules, packages inside of one module strongly together. So we have high cohesion and strong coupling actually in one module. As you can see over here in the diagram, these are modules, and in there they have a lot, they are working strongly together. They have high cohesion. They are fulfilling one responsibility together, and for that they have to work together. Other responsibilities, they should be separated into their own module. This is another very nice principle, separation of concern, that Dijkstra gave us back then in the 70s. Outside the module, we want loose coupling, which actually means low coupling. We will talk about that later. So, which means one module doesn't need much from another module. You can see this as well in the diagram. Between those modules, there is always only one connection. They are not working strongly together. From outside of the module, only relevant features should be visible and accessible. We call this information hiding in our discipline. Details of the implementation should remain hidden. And of course, this, from another point of view, is as well separation of concern. So a good microservice architecture that follows these principles should look like this. It should look like this. What we see here are 3 microservices. Each of them should have one responsibility and therefore have high cohesion within. Of course, there is some technical layering in there, but the key point is that we should build this architecture in such a way that we have as little coupling as possible between the microservices. This works well with Conway's law that some of you might know already. Conway's law that tells us that architecture will follow the organization. This is why we changed our idea of organizing teams following the technology towards cross-functional teams. Before, we had a front-end team and a back-end team and a database team maybe, but they had to talk to each other a lot to create a good software and a good architecture. And often they did not succeed because these teams created cohesion towards their technology. And today, this is why we favor cross-functional teams that try to create business value around separate business responsibilities. They have less communication, as you can see. They need less communication with other teams. And what you can see here is then high cohesion and loose coupling. Each microservice belongs to one team that is responsible for everything within this microservice. So there is a person for the database, there is one for the UX design, and so on. But this is only possible if there is an idea of a domain architecture. Domain-driven design has given us the knowledge to create independent microservices. This was the wonderful moment in 2012 when microservices were connected to domain-driven design. What you see here is one microservice for a sales context and another one for a support context. Having different bounded contexts, different domain models for each microservice. This is such a wonderful idea, and it really works. It creates microservices that have high cohesion and low coupling, which means that you have dependency control. But there are a few pitfalls along the way, and I'm going to show you these pitfalls so that your microservice architecture will have a better shape, or will become will get a better shape over time. So the other day, a client called me and said, Carola, we need help. We are having a microservice architecture. Yes, I thought, finally I get to see one. Well, we have a microservice architecture for our platform where customers can sell their second-hand vehicles. Okay, interesting domain. And we have 270 microservices. Whew, quite a lot. And what is the problem? Well, if we want to change something in the database, we have to discuss this with all teams. What? Well, we looked at the thing, and each microservice was using a library called Model Jar. I asked them what this is, and then they said, well, that's the interface to the database, the one and only database. When the second microservice was built, they thought that they could reuse the work of the first team on the domain model. So the model jar is the domain model, and they took this model jar and they enhanced it for their purpose and ended up with an overall domain model. And that's one of the big pitfalls of microservices. Well, already in the 90s, some companies tried to create the overall data model for their enterprise. I don't know if you have been in the business already, but I remember, and I know that after 10 years and a lot of money that was spent on consultancy and so on, the idea was dropped everywhere. It was much too complicated because no separation of concern, high degree of coordination between teams, and a lot of coupling. It was already then a big ball of mud. And the reason why this happens today is not the overall data model, but our training as software developers. We were taught to reuse classes and source code that is already there. They said, don't repeat yourself. That's what they told us. Code should only have one single point of truth or one single point of maintenance. The danger that is painted on the wall is duplicated code. Ugh, you should never have duplicated code, should you? Well, I have an example for you to illustrate the problem with a real world source base. This is a company that called us to look at their architecture and to help them to divide it into microservices. I asked them, what kind of architecture do you have? And they said, well, we have layers, but actually our architecture follows use cases. And I thought, wow, this finally is not a technical layered architecture, but this is a criterion from the domain. This will be exciting. And what you see there on the left side is the architecture that we put on the source code with a tool. This is the Sotograph, an architecture analysis tool. I have slides later on with other tools, so you can, the tool question will be answered later, okay? For each use case, we have created a rectangle over here and written the name of the use case next to it. Up here you have mailing, import, export, remove, and so on. The dependencies between these system parts are shown on the right side of the diagram. The green arcs represent relationships from top to bottom, as you can see here on this little icon, and the red arcs represent relationships from bottom to top, but it's not so important that it's green or red. It's just important that they are there. And well, if you look at it, you could think, well, mailing uses import, export, remove too, but then there is no connection. So maybe these three up here could form one microservice. Is possible, huh? Well, and after collecting all these use cases, we came to a part down here called model. You guess it. Again, the model jar. This is not possible in a microservice architecture. So we tried to distribute the classes from the model jar among the use cases. This is something you can do with tools like this. If you click on the plus here or here in front of the model, you will see the package tree and all the classes in there, and you can just take them and move them into other use cases or modules up here. We tried this. We tried to move them upwards to all the use cases, and on the right side now here you can see the result. I think we stopped when we arrived at calculation, because now you can see there are so many dependencies between the use cases. They appear now because we moved the classes from the model to the use case rectangles. And so many dependencies are hidden in the model. So what we see here is another big ball of mud. So please, if you are building or having a microservice architecture, divide your domain into subdomains with smaller models, because with separate models, you will allow independent changes which follow the principle of separation of concern. You will represent a smaller set of requirements per microservice, and thereby you will have high cohesion. If the models have clear boundaries, then we will have loose coupling as well. And if this is done, the model and the domain will be small enough so that your team can work, your different teams can work independently. Otherwise, your teams will feel like the chickens on the right side there. The chickens eat pieces of bread, but unfortunately, someone has tied those breads of pieces together with ropes, and the chickens, they swallow them, and now they are no longer independent, and they might even die together. This is what happened. What happens if you have a model jar. So let's look at a solution. This is a banking example with 3 business areas: the account managing, the credit business, and the security business. And these 3 areas, they all use account, customer, credit, and security. Of course, they need something like an account or a customer to fulfill their work. But in a good microservice architecture, this would look like this. If we want to break them down to the bottom of the domain model, we have to have much more specific domain classes: a credit customer, credit account, as well as a security customer and a security account. This is the difference. We will have specific classes for each microservice that have just what they need to fulfill their work in this microservice or bounded context, as we say in domain-driven design. So if you follow this advice, you will have separated models for all your microservices, and each team can then work freely on their own domain model. They know their limits for their microservice, and they stay inside of their boundaries. If we look at our architecture as a hexagonal architecture, you will have the domain application core in the middle, as you can see here, and the technical source code around. Let's now put the separation of domain models into this hexagonal architecture. The domain application core will be divided into slices that go from the domain model to the domain services up to the application services. We can, in general, we can make one basic rule clear here. Reuse should not be done in the domain application core. The domain core is the area of the software where it's about small models that are implementing specifically for their respective microservice, no reuse. In the technical source code, on the other hand, reuse is very important and self-evident. Nobody will implement a database interface specifically for their microservice, but existing technical frameworks and libraries should be reused. So this is a basic and general rule, of course. The second pitfall I come across very often is called one microservice per aggregate or entity. This sounds nice in the first moment. We have one aggregate or entity account, and we control the access to this account with the account service. And we do the same with the customer and the credit and the security. This idea sounds great in the first place, but it's somehow funny because it reminds me of one of the common solutions from early 2000. Let's look at an example. The other day, a client called me and said, Carola, we have several separated microservices, but the customer is everywhere, spread around the whole system. Here is the customer, and here, and here, and here, and here, and here, and here. This is not good. We want to have better microservices. We want to create one microservice called customer service, where all data and functionality of the customer is collected and merged. And then we will delete the customer from all the other microservices. This is a much better solution, don't you think? Well, I had to disappoint this client. No, we don't want this because it increases the number of dependencies and it reduces cohesion. All 4 microservices need to call the customer service now, where all data and functionality of every other service becomes visible. Before, we only had 3 calls with some customer data transmitted. What this client was heading for was a service-oriented architecture. This is something we did in the 90s. It's okay to have or want service-oriented architectures, but a microservice architecture is not a service-oriented architecture. You remember? We wanted the customer all over the place in all the microservices. We don't want one service for all the customers because that will increase the amount of coupling in the system and that will reduce the cohesion. But how do we do that? Well, our software system supports users in their work in a domain. Domain-driven design tells us that in a domain above a certain size, there should be subdomains. So we should find subdomains that can help us to divide our software into so-called bounded contexts. Each bounded context sets explicit boundaries for individual domain-oriented parts in the software and you know that already, in the team organization. We do all this because our goal is high cohesion and loose coupling. To find the different subdomains, domain-driven design recommends us to explore the domain together with users and developers. Two techniques have developed in recent years in the domain-driven design environment. They are called event storming and domain storytelling. These are both workshop techniques that facilitate collaborative modeling. For an event storming session, we meet with our customers and developers and model the process with domain sticky notes on the wall. Of course, today in Miro boards, each sticky note represents a domain event, and all participants are invited to stick notes, which are then discussed and sorted with the whole group. This way you get a quick overview of the process and think about the software. Today, of course, I told you already, we do it with Miro board. In a session with domain storytelling, we also meet with the user and developers and model the process for the domain with actors who exchange domain objects and concepts. Let's have a look at this with an example. This is a domain story for a small art house cinema. In this program cinema, there is the cinema manager and the ticket agent. Once a week in this cinema, there is issued a new weekly schedule for the next week, for the program of the next week. The process starts in the upper left corner when the advisory agency sends the plan for the advertisement bookings. So it's the ad agency, yes, it sends the advertising bookings. And when the cinema has the cinema manager has received this plan, he starts to work on his weekly schedule. And he uses his wonderful system. He loves his system. It's called CineSmall. And the little yellow arrow on the weekly schedule shows that he is working with his wonderful software, CineSmall. The next step is that the cinema manager gets a plan from the film distributor about possible films that he could show in his cinema. And he looks at the national-wide numbers of visitors, and then he negotiates with the film distributor which films he can get, how much it costs, and finally, he finalizes his weekly schedule. And our legacy system, CineSmall, that our cinema manager is using, generates an auditorium plan for each auditorium, so that the ticket agent can start to sell tickets for all these new scheduled film shows. And the moviegoer now comes to the cinema and asks for tickets for a certain film, and the ticket agent checks the auditorium plan for this film to see if he can find suitable seats, then he sells these seats to the moviegoer. Okay, so this is a domain story that we created with the users and the developers who know CineSmall. And the question now is, well, how do we divide this into subdomains and then cut our software into these pieces? Well, if you look closely at this process, you see there are two entries, that is two triggers that set different parts of the process in motion. This is an important indicator that there could be two subdomains in this domain here. In addition, the two subprocesses are also decoupled in terms of time. The left one is performed once a week, and the right one whenever the moviegoer comes by. So much more often every day. And in large cinemas, there are also departments for these two sub-processes, the cinema management and the ticket sales. So this is a good indicator as well. But the best indicator ever for dividing software into microservices is found in the middle. When the left subprocess is over, there's a flow of information in one direction into the other subprocess, and it continues there with the ticket sales. A way back is impossible. This is a very strong indicator of a boundary between two subdomains. The work in one subdomain is done, and the result is passed on to another subdomain. And in the second subdomain, work is continued on the result of the weekly schedule that the process on the left side has created. The question is now, what does this mean if we put this system into software? Where do we cut? How does our system should look like? And in a good solution, we would have two bounded contexts. And the good solution will appear on the left side and the bad one on the right side afterwards. So we would have a bounded context cinema manager and a bounded context ticket sales. The bounded context cinema manager would provide a user interface for scheduling the weekly schedule. This user interface works on a service that allows you to schedule movies in theaters, to schedule advertising for movies and for other things. And the service itself uses a weekly schedule and creates auditorium plans when the work is done. The bounded context ticket sales would provide as well a user interface, but for the ticket sales. It would have a service as well, a service that allows you to search for films and halls and book and sell tickets. Perfect. And this service itself also uses the weekly schedule and the auditorium plans and, of course, the tickets. And to communicate with each other, the two bounded contexts exchange the weekly schedule and the auditorium plan. But this processing between these two bounded contexts, or later between two microservices, is done asynchronically. They don't depend on each other. The ticket sale context can sell tickets for all the weekly schedules that are already done. And he doesn't depend on the other bounded context or the other microservice to do its work. The bad solution would divide these domains according to the entities involved in the process. And here we will need direct coupling. And this solution would look like this. We would have a service weekly schedule and a service auditorium plan. One service for each entity. Both entities would be protected by a service at their interface. And the methods that are necessary in each service are shuffled a bit around, because to search for times for films, you need the weekly schedule, and the auditorium plan can't give me this answer. And generating final schedules doesn't work in this bounded context either. It has to call another method on the other side. So here we have the first direct synchronous connection between those two bounded contexts. And if we go on, the user interface will work on them, and the ticket sales will need those two services to fulfill its work. And the tickets will probably be in another context as well. So what you see on the right side is a division according to entities with direct coupling. This is something you should never do. You should always go for the left side if you want high cohesion and loose coupling. I hope I have shown you now, given you now some ideas about what we do if we want loose coupling and high cohesion in our systems. We have developed over the last years a technique to analyze software systems for their modularity. We do that with something that is called the Modularity Maturity Index. So if you want to know where your system stands, we can help you to discover that. If your system is rated 0 to 4, the modularity is poor. If the modularity is mediocre, we will give you a grade somewhere between 4 and 8. And if the modularity is good, the system gets 8 to 10. This is the x-axis, and the y-axis just represents the time. And now you can see different cycles here. Each of them stands for a system, 16 systems. We started over here with this one, and then we did this one, and then this one. So on the y-axis, it's only the time. The size of the systems, you can see from the size of the balls, and those up here are good. They are green, and then there is some yellow and some red. This system over here is a Java system, and it has 14 million lines of code, and it's very modular. This one is as well Java with a very bad modularity, and this one is as well Java. It's okay, but not good. It's in the yellow area. And this one is C#, and this one up here too. So you can see that it's not the programming language. The programming language really has little influence on the modularity of the system. It's only if the developers and architects have an idea about modularity, about high cohesion and loose coupling, then you end up here with a good result. Tools to do these analysis, there are free tools, like you probably have SonarCube, but there are some others. They are all free tools. You can just download them from the internet. If you want to do real architecture work, you need some commercial tools. I have shown you some pictures from SotoArc and SonarGraph, but there are wonderful other tools as well. And I hope I gave you some information on a good microservice architecture. Never forget high cohesion and loose coupling, and do it from the top to the bottom as well in the domain model and in the database. And then you will be fine with your architecture. Okay, so this was my speech, and I have a look for your questions. Slides will be available afterwards. Yes, of course, Andreas, they always are. And if not, you just send me an email and you will get them. Kevin put in some remark on ArgUnit. Yes, ArgUnit is really a wonderful tool to check your architecture. We are using it all over the place in our company, and I can highly recommend that. Are there other questions on microservices, on the things that I told you? General question. I know these sessions are recorded, but will they be available to watch? I don't know. This is something that the organizers have to answer, I guess. I'm gonna stop this presentation. Doug, I think you have to ask someone else. Oh, in English and in German. All sessions are recorded and will be published on YouTube channel. If you subscribe to the channel, you will be noticed. Voila. Thank you, says Doug. Okay, so if you don't have any questions, Andre says, so you don't see that much of a problem in redundant business logic across classes. No, I don't see much of a problem, because my experience is that the logic is not redundant, because what I tried to show you with all these examples was that the business logic very often gets into huge classes with 40, 50 methods as an interface of the class, where each bounded context try to work with the customer on a different, and they need just one part of the interface and not the whole one. And everyone needs only a bit of this class. and they get so complex and big. And if you cut them into pieces, of course, some things are redundant. The customer number, the name, probably, maybe the address, but not every bounded context needs the address. So there already, the redundance is not so obvious. So from my point of view, if you do it in the right way, the business logic is very specific for each bounded context, and it will not be redundant. Would you allow data duplication due to microservices? Yes, of course. In the database, each microservice has its own database or database schemata. It depends how far you will go, but the customer will be in each microservice database part where it's needed. I guess the customer is something that you need almost all over the place, but each microservice will have only that part of the data of the customers that this microservice needs. And there is some duplication, yes. And you need solutions to get these duplications synchronized, of course. I'm a developer, not an architect. I have a general understanding of cohesion and coupling, but you define those properly. What is the difference between them? The difference between cohesion and coupling: cohesion is about things working together, and cohesion means that they are closely together. They need each other to work, and coupling is the dependency between the outside. So if you think about a package, for example, there are classes in the package, and these classes in the package should have high cohesion to fulfill the job they are doing. They should work strongly together, but the outside, the other packages, there should be only a loose coupling. They don't need much from anybody else to fulfill their work because they are all together to fulfill their work. This is high cohesion. And the coupling is the connection between things. And we just say we want high cohesion and loose coupling, like opposite things. Any tips on migrating from a customer service to the microservice customer? Well, of course. What we normally do is we copy the domain model classes. So the customer class, the big customer class is there several times and several different microservices, and then we reduce them. We downsize the customer class until it fulfills only the needs of this microservice. Yeah, someone knows, Andrew knows the problem of huge classes. Single source of truth, for example. Daniel, I'm not sure. We don't have a single source of truth anymore. So that means you desire high dependency within the package, but not between. Yes, I mean, package was just an example. I desire this on any level, between classes, between packages, between modules, microservices, whatever you think. And Andreas says, I think the loosely coupled API versioning helps in order to release independently. I'm not an expert on AP versioning, so I'm not really the best person to answer that. But I hope that these APIs, they are small, you know, the smallest API that you have to offer to the other service, because you can fulfill your job on your own. Yeah, I mentioned PLSQL, yes. Well, well, there is one. I'm sorry, the slides are already gone. Wait a second. I show you and go backwards. Lattice. This is a tool from the MIT in the US, and it's able to analyze anything, but it costs a lot of money actually. So what we did is we wrote a little parser that parses PLSQL structures and stuff, and we look at that with a Soto graph as well, with a Soto arc and Soto graph. But it's not the same as for a Java system. This, you have to know that. Okay, so we have to finish now, they say. Is there another last question out there for me? Or are you all happy and ready to go to the next session? I hope so. And I wish you a good conference. Have fun with everything that's going on here. Thank you very much for being with me. Thank you for listening to me. Thank you for being there at that late hour of the day, or wherever you are, I don't even know. And thank you for your nice comments. And I hope very much that we meet again soon. That you will find me on Twitter, in the internet. So if there are any questions, just contact me, and I will answer whatever you have. Okay, thank you. Bye bye. Bye bye.